Using work order as reliability data source to calculate equipment MTBF is a common practice in many big organizations. Meanwhile, there are also many software vendors exploiting this demand by providing applications that extract work order data to generate MTBF values for the corresponding equipment. This video describes the flaws in using work order captured in CMMS system to derive MTBF of equipment. First, I will state the obvious assumptions when you use work order to derive MTBF. I will then explain the issues associated with these assumptions in practice. To derive the MTBF from work order, the following assumptions are made by the software developer. Assumption 1. Each corrective maintenance work order for an equipment corresponds to its failure. Assumption 2. Repair start time to repair end time of corrective maintenance work order of an equipment is considered as equipment downtime. Assumption 3. The duration between two corrective maintenance work orders of an equipment is considered as uptime for that equipment. Now, let me describe the issues that contradict the aforementioned assumptions. Problem 1. A failure may have multiple work orders. It is common to see multiple notification order or work orders being issued for a failure. This may result in multiple counts for that failure. Analyst needs to ensure work orders that refer to the same failure are combined as single event to avoid repeated counts on the same event. This sounds simple, but it is not an easy task. If this problem is not handled properly, the first assumption will be violated, and we have a serious error in failure count. And this in turn will have severe impact on your reliability analysis later on. Problem 2. Error in downtime calculation. Let me illustrate the second problem with an example. Consider a crude oil transport pump system that consists of 3 pumps, Pump A, Pump B, and Pump C, operating with a 2 out of 3 standby configuration. On day 50, Pump A failed. Work order was raised and repairs started on day 70. And the pump was restored on day 80. We can see very clearly, the actual downtime for Pump A was 30 days. But repair time was 10 days according to maintenance work order. You will therefore underestimate the downtime impact if you are using it for your RAM analysis later on. To correct this error, the analyst needs to look from the corresponding notification order for malfunction start time. This means that the assumption that the time difference between repair start and end times represents downtime is not valid. Problem 3. Standby durations cannot be derived from CMMS. Let's look at this example. The diagram here shows the operating profiles of 3 identical gas turbines, working with 2 out of 3 standby configuration, over a period of 900 days. If we rely solely on the CMMS system, we observed 5 failures over a span of 900 days. But it doesn't provide data on each unit's standby duration. When we account for the combined downtime of all gas turbines, which totals 80 days, the MTBF is calculated to be 524 days. However, this calculation is not correct because it gives credit for equipment while in standby. Here is the correct way to calculate MTBF. First, derive the uptime of each unit as shown. Since we assumed that the 3 units are identical, we can calculate the MTBF by summing up the uptimes and divided by total number of failure. In this case, the correct MTBF value is 200 days. Relying solely on CMMS work orders causes our results to significantly overestimate the reliability of the asset. Problem 4. Work orders do not capture downtime events caused by process upsets. Typically, when downtime results from reasons other than equipment failure, work orders are not generated, and consequently, the associated downtimes remain unrecorded. Failing to account for these types of process events can lead to an overestimation of the system's reliability and missed opportunities for reliability improvements. CMMS systems are typically designed by accountants and serve as excellent tools for accounting and financial purposes. However, it is unlikely that a reliability engineer is involved in the system's design, and as a result, the requirements for reliability analysis may not be adequately considered. A data collection system for the process industry should, at a minimum, capture the following information: downtimes with associated failure modes, downtimes due to process events with root causes, equipment on standby time, daily production. Relying solely on work orders as the primary source of reliability data can be a recipe for failure in an enterprise reliability program. The objective of the data collection system is to capture events such that historical operating profile can be reproduced with reasonable precision. This allows the analyst to derive the failure rate behavior and downtime distribution of each critical equipment accurately. Thank you for viewing this video. You can also view the text-based article for this video using the link provided here.